welcome back to Golang tutorials. This is Delodese. So in previous episode we went through the for loop. In this episode we're gonna see some jump statements like switch, continue and break. So if you haven't watched the previous episodes, just click on the links appearing here. Again, let's dive into the in here. The first thing, I think it's all pretty messed up here. Just get rid of this thing. We just get this thing also. So as you have seen for and switch, the normal execution is like this. The execution starts here. This is the next statement that's coming after for. So there's a for or switch. Inside that there is some execution statements, and before that there is an if statement. So what happens is when you start the for or switch, it starts with there is an if statement in which there is a condition like that. There is an if statement, it checks something, and then it goes and some other statements follows it, and again it goes back to for. Then this cycle continues. So switch is a bit different, but I hope you guys understood what it means. So when we include the break, what happens is here it goes here, there's an if statement, it checks some condition, and if the condition turns to true or something like that, it asks for a break. So what happens is in the main execution, you'll get some color, something like this. What's wrong here? Add a new layer. So suppose this is a statement, that's the for loop statement, and this is the next statement. So what it does is that after doing the break, it will go to the it will directly break and go to the next statement in the same context. Same context means the same context of the for or the switch of the loop that we are running. There is only one loop in Go, that's for. So in that context, from the same context which having the for loop, it will break down to the next statement in the same context. Don't confuse with the context here. It is not breaking to the context of the inside for, it's breaking out of the context of the for loop. So it will break and go to the statements. So similarly, it has the similar kind of running with continue. In continue it's a bit different, but almost idea is same. What it does is, if we give a continue statement inside this if, it will, instead of breaking out of the for loop, it will just break out of the current context. It won't, after this, if there is some statements are remaining here which has to be executed, it will neglect, it will overturn the statements, means it won't execute the statements, and it will directly go to the for loop iteration, but it will start the next iteration. That's how the continue works. And go to works very simple way. What it does is that it will directly go to the break a point that we are specifying. So this is the basic working. I think it might not be that clear without an example. I will just go to the example. I just have made something earlier. So the basic example, one will start like this: for x equal to 0, x less than or equal to 10, x plus plus. Here we have an if statement, that this is the same if statement that we were giving here. If x equal to 5, then what we does is that we will continue. Continue, and then we'll here fmt.println x. So let's see what happens. This is the if statement that I was talking about, and this is the other statement. This is the other statement. This is the other statement, and this is the if statement. Okay, and this is obvious the for statement. Okay, let's run it. Okay, go run jump statement.go. So it printed 0 1 2 3 5 is missing, and 6 7 8 9 10. 5 here, what did it was we continued. So when it reached here and it found that x is equal to 5, then it continues. So instead of going to this statement, it directly went here. So it skipped the following statements, and it skipped out of the current context. Okay, so what if we give break? Let's see the difference. Here it printed only 0 to 4. So what it did was it break out of the context corresponding to the for loop, the context where all these things come. Okay, so continue breaks out of the current context, while break breaks out of the parent context. Okay, so there is one more interesting thing, that's the use of label. Before that, we will use a loop. Okay, we'll say, okay, we have to take care that this thing don't happen. Okay, we'll just go here, we'll make an label here. Label, what is the label? We just print line hi version. Fine, so we got the label. We'll just go to label. Okay, look, for break, continue and go to, label is an for go to its label is must, but for continue and break there is an optional label which we will be seeing right now after this. Okay, so hi coach, after that it directly went here. Okay, we can just check one more thing. We can just put one more statement here. So, hi, I want be executed. Okay, this guy might not be executed if x value don't get to 5. Okay, it didn't execute because x value got 5 and that went to this label. So this is how we can break the program and go to one label to another. So what if we use label for continue? Okay, okay, here the trick comes. Okay, you just watch. Okay, label is different but not useful. Okay, so you can see when we used it here, it didn't work, just because what continuous normal working is that it will break out of the current execution and go to that label. Okay, you can see in the parent context there is nothing called label. Okay, so what if we take it here? Okay, we take it from here and put it here. Wow. Okay, now we got the 5 missing again, but look at this, I won't be executed, got executed. So what it does is that it goes to a label in the parent context or above. Okay, it's in the parent context, so this label is in parent context, so it got executed. So what it does is it breaks out of the current execution cycle and looks for the label in the parent execution cycle. So it found the label and it went there. So what if we do the break here? It was this break should work the same way as it should have. Okay, work like the similar way. But what if we give one more loop here for y equal to 0, y less than or equal to 3, y plus plus. Okay, it's the outer loop, so we will just put it here. We just remove the high one executed. So we break the when we use this, it breaks out of the this execution and go to the parent execution, isn't it? So let's look what happened here. So 0 to 4 it executed, okay. So but here you can see it didn't execute this loop. This is because the way the break takes the label is different from continue. The way break take is it will break out of the context corresponding to the label that's given here. So the context it was given was this for loop, okay. It breaks out of it, but okay, that's how it worked. So what if we give continue here? So here instead what should happen is that it breaks out of the current execution cycle, and it should go to the parent execution cycle, and in the it search for the label and start again executing the loop from there, okay. So it should print, okay, look at this, it got from 0 to 4, then again 0 to 4. Okay, so it executed from this, it broke out of this execution cycle and went here and continued from here. Again it happened 3 or 4 times. I think it happened 4 times, 0 to 3, so it's 4 times. So in break it was just reverse. It breaks out of that context which is given to the label, in the named label context. It breaks out of that and go for the normal execution, okay. That's the way go to and continue and break. I think that's enough for today. Thanks guys, stay tuned, love and peace. If you like the video, please subscribe to the channel.